This video will provide an overview about risk analysis, its importance in a city's asset management plan, and how risk analysis are calculated in Info360 Asset. Let's start by asking, why is risk analysis important for a city's asset management plans? Mainly because it allows cities to manage their limited monetary and labor force resources by optimizing the cost and work allocations during every planning period. This results in cost savings and improvement in the health of their systems. So what can be accomplished with the use of a risk analysis? Asset prioritization. In other words, focusing the city's resources on the assets that have highest risk of failure. Asset failure prevention, by repairing assets before they fail in a proactive instead of reactive action plan. Pollution prevention, by preventing polluting events such as sanitary sewer overflows. Optimization of day-to-day operations. And informed decision-making, by considering data from variable sources such as GIS, CCTV, CMMS systems, and hydraulic models. Info360 Asset allows users to categorize all of their system assets based on risk scores and grades. This risk score is calculated from data available in Info360 Asset, such as pipe attribute data from asset GIS layers, condition scoring from CCTV inspection data, and data from external sources such as CMMS work order data. The result is a summary that will highlight assets with extreme or high risk, which will have to be prioritized before assets with medium, low, or negligible risk. Let's do a recap on how risk analysis in Info360 Asset is calculated. A total risk score is calculated from the total scores from likelihood of failure parameters, or LOF, and consequence of failure parameters, or COF. In the water industry, likelihood of failure defines how likely or probable it is that an asset in a system will fail. Some examples of this criteria might be the age of the asset, the material of the asset, or the history of failure of the asset. On the other hand, consequence of failure defines the public health, environmental, or economic hazard of an asset failure in a system. Some examples might be the proximity of the asset to a major road or the proximity to rivers or streams, which will cause a high severity pollution event. Let's look at an example of a risk breakdown for different LOF and COF categories, which might be comprised of one or more components. In this example, the risk will be calculated as the summation of the total likelihood of failure, which will have an 80% weight of the total risk score, and the total consequence of failure score, which will have a total of 20% weight of the total risk score. The LOF portion is comprised of 4 categories. As a condition, we will have a total category weight of 70%, pipe material, pipe age, and repair history, which will all have a 10% weight to the total LOF score. On the other hand, the COF is comprised of 3 categories. Impact on critical facilities, which has a total weight of 50% for the total COF score, and impact on surface water, and impact on transportation, which will each have a total of 25% of the total COF score. As summarized in this table, some categories might be comprised of more than one component. For example, the critical facilities category scores proximity to hospitals, proximity to police stations, and proximity to fire stations separately but combines the scores to get the maximum value of the 3. In another hand, the impact on transportations category scores proximity to major roads and proximity to railroads separately, each having a 50% component weight relative to the total category score. Now, before explaining a couple of risk examples, let's go over assumptions that apply in Info360 Asset. Let's consider a scenario where the pipe has condition data. In Info360 Asset, you have the choice to A. Use 100% of condition score as the total LOF score, or B. Use condition score and score from other components to get a total LOF score. Whichever option you choose will depend on how much importance you give to your condition data from CCTV over other variables such as pipe attributes or other likelihood of failure criteria. Now let's consider a scenario where condition data has not been collected for a pipe and not available in Info360 Asset. In the total LOF calculation, the condition category will be completely excluded. This means the other LOF categories will have a higher impact to the total LOF score, and the weight for these categories will have to be adjusted either manually or automatically in Info360 Asset. Now let's look at an example for a pipe that has condition data. This pipe scored a 10 in the condition component because of a high severity deformation found in a CCTV inspection. The pipe scored a 5 because of the vitrified clay pipe material. It was installed in 1930s, which gave it a score of 9 under the installation year category, and it has a score of 5 under the count of past repairs component because it has had 5 repairs in the past few years. Based on all this scoring, and considering the LOF calculation, this pipe has a total LOF of 7.44. On the other hand, this pipe scored an 8 under the Impact on Critical Facilities category because of its proximity to a fire station, a 9 under proximity to major roads because it is within 500 feet of a major highway, and an 8 under the proximity to railroads component. Based on this scoring and considering the total COF calculation, this pipe has a total COF of 1.225. Adding up the scores of total COF and total LOF, an 8.67 out of 10, which gives the pipe a risk grade of extreme. Info360 Asset calculates risk for all the pipes in your system, categorizing them based on severity and facilitating the prioritization process for cities, saving time and money to all of our users. To view more examples of risk calculations and documentation to help you create your first risk analysis, please view the links and download sheets in the video description below. Thank you.